Okay, so today we're going to cover lesson 5, and today is going to be rational functions. So if you remember the definition of the word rational, it means that any number that can be written in fraction form. So our polynomial functions are going to be fractions. So our simplest rational function is this one that's written in red, and it's y equals 1 over x. Now, if I were to ask you to graph this, and if you didn't have your handy dandy graphing calculator, it would be kind of a tedious process because we would have to take different x values and plug them in. But I'm going to show you this because it's pretty simple, because all we have to do is take whatever x we want to plug in and put it underneath a 1. So if I were to make a table of values, I would plug in my numbers. And I'll first work with just the positive numbers here. I could do another table over here for the negative numbers. So -1, -2, -3, even jump to 20 here. Okay, so for here, I'm just going to take my function and I'm going to put 1 over 0. Uh-oh, what happens when I put 1 over 0? It's not working, it's undefined. So there's actually, in your calculator, there's not going to be anything here. It'll probably even say the word error. So anytime that it's undefined, you're going to see the word error in your table. So then if I plug in 1, it's 1 over 1, and that gives me 1. If I plug in 2, I get 1 over 2. If I plug in 3, 1 over 3. And this is how I would have to get order pairs to graph. I could do the same thing over here with the negative numbers. And I would get -1. Here I would get 1 over -2, 1 over -3, and so on. So this is how I would have to get ordered pairs if I didn't have a calculator. So when you go to graph yours, what you're going to key in your calculator is you're going to go to the y equals button, and then what you could do is put 1 and then divide it by x and then hit enter. And then it would give you the graph. The graph of this looks like some boomerangs. So if you happen to be keying this into your calculator, this is what should be appearing on your screen. Now, notice it's been separated. And these separators are called asymptotes. So we have a horizontal line here. That's a horizontal asymptote. And then we have the vertical asymptote. And what these are doing is it's going to be a vertical and a horizontal line that our graph will approach, but they're never going to touch. Now, there are a few situations where the graph may bump into the horizontal asymptote and even cross it, but it will never cross the vertical asymptote. So let's go ahead and see the official definitions. So a vertical asymptote is just a vertical line that a graph approaches but never touches. You're going to be required to calculate this vertical asymptote, and the way that you do that is you're going to set the bottom of the fraction or the denominator equal to 0. Now we've done this in the past where these were the values that we excluded from our domain. So we're just going to set the denominator equal to 0. Now, for the horizontal asymptote, this is going to be a horizontal line that the graph approaches as x goes to infinity. Okay, most of the time it's going to be a line that the graph approaches but does not touch. Occasionally it can cross it, but it's always going to get closer and closer to it as it approaches infinity. So there's going to be 3 different situations to find this horizontal asymptote. Now there is a typo here. I did copy, cut, paste when I made these notes. So for this first one right here, and change this less than symbol, and I want you to change it to an equal sign. So when the degrees are equal, the way that we'll find the equation for our horizontal asymptote is we're going to take the leading coefficient of the numerator and put it over the leading coefficient of the denominator. And it'll be y equals. And I'm going to do an example of this. So for example, we're going to look at the exponents to get our degrees. So for example, if you have 2x squared over x squared, or divided by x squared, if this is your function, then to get the horizontal asymptote, I'm using the leading coefficients. What I'm looking at is this exponent. When the exponents are the same, my horizontal asymptote occurs at 2 over 1, which is the same thing as y equals 2. Let me try another one. Let's say it's y equals x minus 5 over x plus 1. Again, notice the degrees are the same, the exponents are the same. So my horizontal asymptote, again, I take the leading coefficients, I assume there's 1's there. So it's y equals 1 over 1, and it's just y equals 1. This is how you would find the horizontal asymptote when the degrees are the same. Now let's look at case number 2. This is when the degree of the numerator is smaller than the denominator. When this occurs, the horizontal asymptote is just y equals 0. When the degree of the numerator is bigger than the denominator, so see how it's a 2 and that's a 1. There isn't going to be a horizontal asymptote. There's a slant asymptote. So we need to do long division. So this is how we're going to practice for the quiz. I am going to turn this function into a long division problem. So I'm going to take the numerator and I'm going to divide it by the denominator. Because again, remember the fraction bar? That's a division sign. So remember also, just like with the synthetic division, we have to hold places with zeros. So I need to put in a 0x here. You will have to do this on the quiz tomorrow. You will have to do a long division problem just like this. So now, when I do long division, I'm looking to see what am I going to multiply x by to make it x squared. I'm going to multiply it by x. X times x gives me x squared. X times -1 gives me -1x. I then change the signs to opposite, and now I combine the like terms. I bring down, I multiply. 1 times x gives me 1x. 1 times -1 gives me -5. Oh, I flipped the signs, sorry. This gives me -3.
Why'd you put +1?
Because what we're doing is we're changing the signs because we're subtracting. So really what we were supposed to do here is x minus 4, and then I had this, but then I had to remember I'm subtracting x and I'm subtracting -1. So it's easier for me to just change the signs and then add them or subtract them if they're different.
Or like on the top where you put that, like
The +1?
on the top, yeah.
Yeah, because I had to figure out what did I have to multiply x by to make it 1x. And I had to times it by 1.
Why was it 1x instead of 0x?
No, because I've now subtracted and I'm trying to make this x. I'm only trying to make the first number, not the second number. Yes.
Is -3 the remainder?
Yes. Now, for our purposes for horizontal asymptote, I would just stop at this point. But for tomorrow's quiz, you're going to take the remainder and put it over what you divided by.
So for this, you don't put a remainder?
Not for this lesson, no. So you would stop and you don't have to put the remainder for this lesson. Because what we're looking for is an equation of the line in y equals mx plus b form. And that's what this is. So this is how we find the slant asymptote. Now let's practice it one more time. Let's practice going through the 3 different scenarios. So again, case number 1, we're going to look at the degrees. On all of them, we're looking at the degrees. So again, when the degrees are the same, see how they're both x to the second power and 3x to the second power? When the degrees are the same, this is where we use the leading coefficients. So it's going to be y equals 1/3. Then for the next one, notice the degree in the denominator is the larger one. So when that occurs, it's automatically y equals 0. When the top degree is the larger one, there are no horizontal asymptotes. It's just going to be a slant asymptote, and I find that slant asymptote by performing long division. So again, take the numerator, it goes in the box. Again, any missing terms, I have to hold the place with a 0. And now I begin the division. What am I going to multiply x by to make it x squared? And that's going to be x. I multiply x times x, and I get x squared. I multiply x times 1, and I get 1x. I flip the signs to opposite, and I get negative 1x. I bring down my next term. What am I going to multiply x by to make it negative 1x? And that will be negative 1. And negative 1 times x gives me negative 1x. Negative 1 times positive 1 is negative 1. I flip the signs. My remainder is 4. Now, for our purposes, for the slant asymptote, I'm just writing y equals x minus 1. However, for the quiz tomorrow, you must take the remainder, put it up top here, over what you divided by. So the final answer on this one would be that, for the long division problem. Now we'll actually do an example, and we're going to do the 4 things algebraically. The vertical asymptote, horizontal asymptote, and then we're also going to find x and y intercepts. But that's the same thing we've been doing all along, where we plug in zeros. So for this one, first thing I can do is find my vertical asymptote. That process is the same always. We set the denominator equal to 0. So my vertical asymptote is going to occur at x equals 4. I'm going to go ahead and add it to my graph. It's a line. I'm going to graph it in red. It's going to be a vertical line through positive 4. So I'll come over here, and this is the line x equals 4, which is my vertical asymptote. I'm now going to find the horizontal. To find the horizontal, those are those 3 cases. I'm going to look at the degrees. Notice for the horizontal, my degrees are the same. So for the horizontal asymptote, when the degrees are equal, this is going to be the coefficients. So it's y equals 1 over 1, and my horizontal asymptote occurs at y equals 1. Yes? When we're done with this. All right, so for here, I'm going to draw in the horizontal asymptote, and it's right here. Let me do it with highlight. All right, that's how you find vertical and horizontal. This is what was the new information. Right now, I need to find x and y intercepts. So remember, to find the y-intercept, I plug in x equals 0. Same thing we've been doing all along. So y equals x plus 1, x minus 4. Take out the x's, put in zeros. So y equals 1 over negative 4. So my y-intercept is the ordered pair, 0, negative 1/4. So I could put a point here on my y-axis. Now I'm going to find the x-intercept. To find that, I make y equal 0. So 0 equals x plus 1, x minus 4. Remember, this fraction bar is keeping these grouped together. So the first thing I'm going to do is get rid of this fraction. So I'm going to multiply both sides by x minus 4. That's going to get this to cancel. Anything times 0 is 0. So I'm just going to solve 0 equals x plus 1. So really, to find the x-intercept, you're just setting the numerator equal to 0. So negative 1 equals x. So my x-intercept is negative 1 comma 0. So I can come over here, put my point. Now to get the other order pairs, you're using your calculator. So what you would do on your calculator is you would key in the y equals button, and then you would hit parentheses, x plus 1 divided by parentheses, x minus 4, and then hit graph. You could also hit second and graph, and then your picture will look like this, 2 boomerangs, one going down this way. Notice how it skims along these asymptotes that we drew in. So the red and the blue line are the asymptotes that our graph is like being bounded by, where it's not going to cross it. So this is going to be the graph for this rational function. So algebraically, you're just finding the horizontal, the vertical asymptote, and then the x and the y intercepts. Okay, so for this one, I need to find my vertical asymptote. Remember, that process is always the same. Set the denominator equal to 0. So I've got a vertical asymptote at negative 3. I'll go ahead and put it on here. I could say it's about here. X equals negative 3. For my horizontal asymptote, I need to look at the degrees. Notice they're the same again. So for my horizontal asymptote, it's just going to be y equals 1 over 1, which is just y equals 1. So it's the same thing again. So here's my horizontal. And then now I'm going to find my x and y intercepts. And again, to do that, you plug in the zeros. So for the y-intercept, we're going to make x equal 0. So this will give me y equals 0 minus 5 over 0 plus 3. So my y-intercept is going to occur at 0 comma negative 5 over 3, which will be down here. It's about negative 1 2/3. So then my x-intercept, make y equal 0. So x minus 5, x plus 3. Again, remember, you're going to multiply both sides by the x plus 3. So then it's really 0 equals x minus 5. Add 5. And my x-intercept occurs at 5 comma 0. So I can put it over here. So again, to get the order pairs, you're going to key it in your graphing calculator. And then your boomerangs are going to be over here. See how it's skimming along that blue and red asymptote? And then over here, same thing. And as it approaches infinity, it's going to get closer and closer to those asymptotes. Yes?
Why do you have to find the asymptotes?
To figure out like where the cutoff is, where our graph can't go through.
So if you just put in a calculator, can you still get the answer?
Yeah, you can get the graphs. You can see where it's not going, and then you could draw in the asymptote. On your calculator, it's going to be error. If you look at the table, it's actually going to spell out the word error. Yes?
So you plotted those two things, how did you get the...
From your calculator. So you're just going to get more order pairs out of your calculator to graph that other one. you can make a table of values. Like remember, if this is your asymptote at -3, you could do a table of values and plug in -4, -5, -6 to get all the points that are here. Does that make sense? But again, we're going to use our calculator because it's just tedious calculations. All right, so number 3.
When we use our calculator, we just copy it off.
Yep. Or you could, if you want a precise one, you could pull order pairs out. But you could just copy it off your calculator. But you're going to be drawing in, or you're going to be telling me where the asymptotes are. All right, so for the next one, I actually gave you a little head start here. To find the vertical asymptote, remember you need to set the denominator equal to 0. And to find out what the value of x is, I got to factor this thing or do quadratic formula or completing the square. So I'm actually just going to factor it, and I already did up there. I forgot to erase it. So then I set each one equal to 0. This time I'm actually going to get 2 vertical asymptotes because it was an x squared in the denominator. So I have actually a vertical asymptote at -2, and then I have another one at -4. So I'll go ahead and add these in red. So I've got one here, and then one here. So then now I need to find the horizontal. Remember, for that you look at the degrees. And for this one, my degree of the denominator is bigger, so it's just y equals 0. So I'll highlight this one in blue. So it's just the x-axis. That's my horizontal. I'm going to calculate my x and y intercepts. So again, remember for the y-intercept, make x equal 0. So 2 times 0 plus 1 over 0 squared, 6 times 0 plus 8. You could plug it into the factored form also. And here I get 1 over 8. So my y-intercept is 0, 1/8. So we could put it right about there. For the x-intercept, I'm going to make y equal 0. So this gives me 2x plus 1 over x squared, 6x plus 8. Again, remember, we're really multiplying both sides by the x squared plus 6x plus 8. So when I do it over here, anything times 0 is 0. This one cancels. So now I'm solving 0 equals 2x minus 1 or plus 1. I'll subtract the 1, divide by 2. X equals -½ So my x-intercept is at -1/2, 0. So over here. Again, we're going to add in all our sections here. We actually have 3 different pieces. So I have the boomerang over here that's skimming along the asymptotes. I have this boomerang over here skimming along. And then I have the one up here, in between here. And again, if you weren't using your calculator, you'd be doing a table and you'd be plugging in like -6, -7, -5. I'd skip -4 because it's an asymptote, -1. And so you can represent every single number. But we're using our calculator for this. Yes?
Wait, so how do you get the boomerang on the left side?
You would plug in values or just look at your calculator. So you're going to use your table of values from your calculator. Otherwise, to get the one on the left side, you'd be plugging in like -10, -9, all the numbers up to this asymptote here, which was -4.
And how do you plug it into the calculator?
Okay, so for this one, again, you're going to hit the y equals button. Then what you're going to key in is you're going to do parentheses, 2x plus 1, close parentheses, divided by, parentheses, x squared plus 6x plus 8, close parentheses, and then hit graph. Because again, remember that fraction bar is division, and it's like a grouping symbol. If you don't use the parentheses, you're probably not going to get the correct graph. Yes?
Do you know how many boomerangs are going to be?
Depends on how many asymptotes you have. So notice on this one, there were 3 different sections that it could cover. So it's all going to depend on your asymptotes. Let's try another example. This one we're going to practice long division some more. Okay, so for the vertical again, same process, set the denominator equal to 0. So I have a vertical asymptote at x equals 4. Remember, for the horizontal, we look at the degrees. When the top is larger, remember there's no horizontal, but we have the slant. Okay, so for this one, I'm going to do the long division. I can't use synthetic for this. It has to be long division. So I'm going to put the numerator in the division box. Again, remember, if there's any gaps, we got to hold them with zeros. And then I'm dividing by the denominator. So again, what are we going to multiply x by to make it become 2x squared? So I'm going to multiply it by 2x. I'm going to multiply it. I also have to multiply it to the negative 4. Flip the signs to opposite. Bring down the next term. What am I going to multiply x by to make it positive 8x? And that'll be a positive 8. I'm going to distribute it. Flip the signs to opposite. Now, for my asymptote, I'm just using the y equals 2x plus 8. For the quiz tomorrow, you need to put the remainder up here. And that's your final answer there. So that's how you do the long division for the quiz for tomorrow. Now, I also need to find the x-intercept and the y-intercept. Okay, so let's find our intercepts. So again, the y-intercept, I set x equal to 0. So y equals 2 times 0 squared plus 3 and 0 minus 4. So 0 plus 3 over negative 4. So my y-intercept is going to be 0, comma, negative 3/4. For my x-intercept, this one's going to be at y equals 0. So 0 equals 2x squared plus 3x over x minus 4. Again, remember we're bringing it up, times it by 0, so it cancels it. So 0 equals 2x squared plus 3, subtract 3, negative 3 equals 2x squared, divide by 2, negative 3 over 2 equals x squared. Notice when I square root it, this is going to give me an I. So there are no x-intercepts. So let's go ahead and put all the other information we have on here. So here I'm going to put all this information on the graph. So I need to graph this line. The y equals 2x plus 8. Remember, this is y equals mx plus b. So my first point, my starting point goes on 8, and then I'm going to rise 2 and run 1. So 1, 2, 3, 4, 5, 6, 7, 8. So I could put my first point here, rise 2, run 1, rise 2, run 1. So then I can connect my dots, and this is my slant asymptote. Then I also need to graph the vertical asymptote, which was 4. So my VA is here, x equals 4. So now I'm going to graph my intercept, which was -3/4 for the y. So now I'll put the boomerang on here. So it's actually going to go right here. So the red line and the blue line are my asymptotes that's bounding that. So that would be that one. One more example where we're going to see some holes. So for this one, I need to factor the top. It's the difference of two squares. Remember when we were simplifying rational functions? Remember you could cancel things. The factor that you cancel, we're going to set that factor equal to 0, which is going to create a hole in my graph. I have a hole that's going to occur at x equals -3. So right now my simplified function is y equals x minus 3. This is a linear function. To find out where to put the circle or the hole, I'm going to plug in -3 for x. So -3 minus 3 gives me -6. So at the order pair, -3, -6, I'm putting an open circle. From here, I'm going to graph my simplified function. Because remember, to find the vertical asymptote, you would set the denominator equal to 0. There is no denominator, so there's no vertical asymptote. For the horizontal, again, there's no degrees to compare, so there's no horizontal asymptote. So then here, my y-intercept is -3. So it goes here, it skips over the hole, and keeps going. So this is how you would graph a hole in your graph. It's sort of like a domain restriction. Remember, the value that x can't be, that would make the denominator 0, is the hole. The chart, if you're looking at it in your graphing calculator, where you see x equals -3, it's going to have the word error because it's undefined there. So it's sort of like the domain restriction. We can still find the x-intercept and the y-intercept. My y-intercept, when I make x equals 0, is just -3. And so it would be 0, -3. And for my x-intercept, when I set y equal to 0, then that would give me the order pair 3, 0. So that is an introduction here to 3-5. On Monday, we will practice this a little bit more. I am going to move the due date for the homework to Tuesday. So your homework tonight, even though we learned this lesson, is just to study for the quiz. Then you've already learned, we went through all the slides, so if you want to start this homework over the weekend, you can, but I am going to move the due date for the homework to Tuesday.